Okay, in this video, we want to determine whether f or the given function is even, odd, or neither. So last time we worked on this example, and we came to the conclusion that this is an odd function, and but today we want to see if g of x, which is x over x plus 1, is an odd or even neither. So because it is possible to just be neither odd or not even. Right, so the only thing we just need to recall before we start doing this question is that this condition which tells us if a function is even or odd. So basically, if you find f of minus x and you get f of x, that means the function is even. And then in the case that while you are finding f of minus x, you get minus f of x, then that means the function is odd. So, and there is the third case that when you find f of minus x, you just don't get any of the above values. And then that's the case when you say it's neither even nor odd. Okay, now let's work on this example. And as usual, let's start by finding g of minus x. So we just substitute minus x into the function, and we are going to have this. Okay, now here we need to figure out if this satisfies any of the two conditions that I just showed you for evenness or oddness. So remember that we can, for example, rewrite this function in this form: minus x over minus x plus 1. So basically, I just put the minus just next to the fraction. And so as you can see, this form probably doesn't, basically doesn't look similar or familiar to us, because if, for example, this function were an odd function, then we had to get something like this: minus x over x plus 1. So this is the case if the function was an odd function, because this satisfies that this condition, minus g of x. So g of minus x is equal to minus g of x. Or in the case that we had even function, then we should have got this. So just x over x plus 1. Basically, we should have got the same function as the original one. But as you can see, the function that we got here is none of them. So it's neither the odd one nor the even one. And then that means that, therefore, this function is neither even nor odd. So let me just get rid of this because they may be confusing. So yeah, we just say that therefore, I mean, we could have kept those as part of our solution, but it's not really necessary because it doesn't satisfy any of the above conditions. So therefore, it's spelling error. No odd, and as it doesn't satisfy any of these conditions. So just for the conclusion, that to show that we know what's going on, we can just write the conditions that a function is even when g of minus x is equal to g of x, odd when g of minus x is equal to minus g of x, and we can see that it just doesn't satisfy any of this. So yeah, it's neither even nor odd. That's it for this video, and thank you for watching. Make sure to like and subscribe the video for the in order to be able to watch the future ones. Good luck.